Hello all, in this tutorial we are discussing about the next operators, okay, next kind of operators which are present in Python. That is nothing but bitwise operators, okay, bitwise operators. In bitwise operators, okay, so let us see what are all bitwise operators, okay. These are, okay, bitwise operators are nothing but these operators will perform operations over the bits, okay, operations over the bits is nothing but binary data, okay. So these operators will perform the operations on the binary data. So let us see all these bitwise operators one by one, okay. First one is nothing but end operator, okay, bitwise end operator. Bitwise end operator will be denoted with a symbol called as end. Okay, bitwise end operator will be denoted as a symbol called as end. So in bitwise end operator, what happens is we have a primary rule in bitwise end operator, okay. That is nothing but if both the bits are, okay, if both the bits are true, then only result is true, okay. If both the bits are true, then only result is true, otherwise false. Now second one is R, okay. Second one is R. So in bitwise R, if both the bits are false, okay, if both the bits are false, then only result is false. In all other cases, okay, in all other cases R operator, okay, bitwise R operator is true only. Now coming to the complement, okay, bitwise not, okay, bitwise not operator will also be called as a tilde operator, okay, TILDE, okay, tilde operator. So in this tilde operator, what we are doing is we are applying the complement of the total bits present in that number, okay. We are applying the complement of total bits present in that number. Next one is nothing but XOR, okay, bitwise XOR. So bitwise XOR will be denoted with a symbol called as cap, okay. With this cap symbol help, we can denote the bitwise XOR operator in Python. Now if what happens in the bitwise XOR means if both the bits are same, okay, if both the bits are same, then result is false, otherwise true, okay, otherwise true. So now let us see all these four operators one by one, how this will work, okay. Now think that I have two values, okay. First let me discuss, okay, let me explain you the first kind of operator, that is nothing but bitwise end operator. And think that I have two variables, one is a equal to 4 and b equal to 5, okay, a equal to 4 and b equal to 5. Now if I denote a in binary format, okay, if I denote a in 4 bits binary format, it will be like 2 power, okay, yeah, 2 power 0 will be 0, 2 power 0 is 1, and so for that it is 0. 2 power 1 it is 0 again. 2 power 2 it will be 1 because 2 power 2 is 4, right. So for 2 power 2 it is 1. Now again it is 0, okay. For 4 in binary format, this is the value, so 0 1 0 0. Now let me denote b, which is 5, in the binary format, okay. So b will be something like this, okay, 0 1 1 0, okay, 0 0 1 1 0, or else, sorry, 0 1 0 1, okay. So 2 power 0 is 1 and 2 power, so basically these are nothing but it will be denoted like that, okay. 2 power 0 is 1, 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, and 2 power 3 is 8. So in this case it is 1 0 0, okay, 0 1 0 0 for a and 0 1 0 1 for b. So now let us apply, okay. Now what I am trying to do here is I am trying to apply, okay, I am trying to apply the end operator, okay. So what operator I am trying to do here? I am applying the end operator, okay. If I am trying to apply the end operator, what happens is primary rule for us is nothing but if both the bits are true, okay, if both the bits are true, then only true, otherwise, okay, if both the bits are true, then only result is true. So here here for okay, 2 bits are 0, so it is obviously 0. Next one is 2 bits are 1. Okay, both bits are 1, so obviously output is also 1. And the 2 bits are 0. Okay, 2 bits are 0 means obviously it is result is 0. Again first one is 0 bit and next one is 1 bit, so in this case it is again 0 only. So my output is nothing but my output is nothing but 0100. So 0100, if I put 0100 in decimal format, what is my value? 4 only. Okay, what is my value? 4 only. So in this way, okay, so in this way we can calculate the we can apply the bitwise AND operator between two variables. Okay, so in this way, if I apply bitwise AND operator between 4 and 5, output should be 4 only. Okay, I hope all of you understand how to calculate the bitwise AND operator. Next we will move ahead with the next operator, that is nothing but bitwise OR operator. Okay, bitwise OR operator. Okay, bitwise OR operator, the primary rule for bitwise OR operator is if both the bits are false. Okay, if both the bits are false, then only result is false. In all the other three scenarios, okay, in all other three scenarios, it is true only. Okay, let us explain this bitwise OR operator also with one example for the better understanding. Now, suppose if the next operator what I am trying to explain is nothing but, so again, okay, now x value I am taking it as 4 and y value I am taking it as 5. Now what operator I am trying to apply? I am trying to apply the OR operator. Okay, OR operator will be like will be denoted with the pipe separator. Okay, with this pipe symbol we can denote OR operator. So now x value is what? Okay, x value is what? 0100 in binary format. Y value is what? 0101 in binary format. Let us do, okay, now let us apply OR operator. So primary rule for OR operator is nothing but, okay, primary rule for OR operator is nothing but if both the bits are false, like both the bits are 0, it is 0. In all the other cases it is 1 only. So in this case only it is 0. In all the other cases it is 1 only. So here it is what? So it is 8. This is 4. This is 2 and this is 1. So in this case my output should be something like 7. Okay, so 4 plus 2 plus 1. Okay, wherever ones are there, that we need to add. So 4 plus 2 plus 1, nothing but 7. Okay, so in this way we can apply bitwise OR operator in between two variables. I hope all of you understand how to apply bitwise OR operator. Now let us see. First we will see the bitwise XOR operator, then I will explain the bitwise NOT operator. Now third operator which we are discussing is nothing but bitwise XOR. Okay, let us see how this will work. Okay, bitwise XOR operator. Okay, bitwise XOR operator. Okay, bitwise XOR operator we will be denoting with the symbol called as cap. With the cap symbol we can denote the XOR operator. Now let's focus on the result. Suppose again x value is 4 and y value is 5. Okay, how XOR operator we can apply, we will see. So XOR operator, how we can apply? Like primary rule for XOR operator. Okay, primary rule for XOR operator is nothing but if both the bits are equal. Okay, see here, if both the bits are same, then result is false. Okay, see in this case it is false because both are 0. Okay, here also false because both are ones. Okay, again in this case what happens? Both the bits are, okay, again both the bits are 0. So in this case again it is false. In this case it is true, because both the bits are both the bits are not equal. So in this case what will be my output? Okay, this is for 1. So 1 will be my output. So I hope all of you understand how to apply XOR operator. Okay, now let us see how we can do the bitwise NOT operator. Okay, bitwise NOT operator will also considered as a tilde operator. Okay, bitwise NOT operator will also called as the tilde operator. So why? Because we are just doing the complement on this. Okay, we are just applying the complement concept on this. So let us see how we can work with bitwise complement operator. So suppose here we will apply bitwise complement for only one value. The symbol is nothing but this one, tilde. Okay, this button will be present in the exactly underneath the escape word. Okay, escape keyword, it will be present in your keyboard. Okay, now if it is 4 means 4 is what, suppose x equal to 4. Now 4 is what in your binary format? So this is the 4, right? This is nothing but 4. Now if complement means what you need to do basically. Okay, complement means you need to find the opposite. So for what is the opposite of 0? 1. What is the opposite of 1? 0. What is the opposite of 0? 1. Again, what is the opposite of 1? In this case also it is 1 only. So here in bitwise complement operator, first letter you should be very careful. Okay, first number you should be very careful. Okay, if first number is 1, if first bit is 1, then negative number. Okay, output will be negative number. If first bit is 0, then output should be positive number. Okay, so in this case first number is what? First number is what? First number is 1, right? So in this case it should be negative. So whenever it is negative, we need to apply the 2's complement. Okay, we need to apply the 2's complement. 2's complement means 2's complement is nothing but 1's complement plus 1. Okay, 1's complement plus 1. So 1's complement means again we need to convert all this into, again we need to apply complement for all this. So in this case it should be like 0 1 0 0. So this is the 1's complement. For this we need to add 1. Okay, for this we need to add 1. So if we add 1 for this, then what happens? 0 plus 1. Okay, 0 plus 1 will be 1, 0 will be 0 only, 1 will be 1 only, and 0 will be 0 only. So in this case what is the value? 0 1 0 1. So then what is the value in this case? 0 1 0 1. 0 1 0 1 means what? 2 power 0. See here values are 8 4 2 1, right? So in this case what is the value? 1 0 1. So 4 and 1. Okay, we need to add 4 and 1. Now what is the value? 4 plus 1 is nothing but 5. Okay, since it is negative number, we need to put minus 5. Okay, we need to put minus. So in this case, okay, if we find out the complement for 4, my output will be minus 5. Okay, my output will be minus 5. So in this way we can find the complement. Okay, complement. So I hope all of you understand these 4 operators. Let us try to execute the same thing in ideally for better understanding. Okay, actually this is how. Okay, internally it will calculate based on the based on the binary numbers, but okay, output will be displayed in the decimal numbers only. But directly if we are running in ideally, we can't get to know what is happening internally. Okay, we can't get to know what is happening internally. So to explain you the concept of what is happening internally, I told you all these things. Okay, if we do the same thing in the real time, if we do the same thing in the ideally, it will come in just a fraction of seconds, but internally all these things are happening. Now let us see in real time. Now let us see in ideally. Now a value is okay, x value is 4 I am taking, y value is okay, y value is 5 I am taking. Now if I apply x and y, okay, x and y, see here, if we apply x and y, what is the output that we got? 4, right? So let us see whether we are getting 4 or not. So output should be 4. Why 4? Because when we calculate manually, the output is 4. Let us see 4 is coming or not. See, okay, in this way we can apply AND operator, okay, bitwise AND operator between two variables. Let us see by applying bitwise OR operator between these two. So when we calculate manually for bitwise OR operator, what is the output we got? We got 7. So let us see whether we are getting 7 or not. Oh, we are getting we have to get 5 only, because if both are 0, okay, here also it is 0, so if both are 0, it should be 0 only, right? So in this case 101 is pointing to 5 only. So in this way, in this case we need to get 5 only. Okay, same 5 we got in ideally as well. Okay, I hope all of you understand this. Next thing is nothing but XOR operator. Okay, XOR operator, if we do manually, what we got? 1. So let us see if we are getting the same thing or not. Okay, x y. Okay, so see, if we do manually, what is the output we got? 1, right? So same way we got 1 when we apply in the ideally, but internally all these things, okay, internally all these things which we did manually are happening. Okay, now let us try to understand, okay, complement also. So complement means what? X value is 4. So if I put the complement for this, after doing all this, what is the value I got? I got the value -5. So let us see whether I am getting minus 5 if I apply complement on x or not. Okay, now complement on x is nothing but -5. See, in this way we can get the complement value, but manually when we calculate, we need to apply all these things. Okay, whatever the output that we got after applying all these things, we got here. Okay, we got here with this approach. Okay, I hope all of you understand how these bitwise operators are applicable internally. Okay, thank you so much. Bye.